Hello, and welcome to this MCMA webinar, Optimizing Automation Machine Development Using Open Standards. My name is Joanna, and I'm the Manager of Marketing and Membership for the MCMA, and I'll be serving as your moderator today. Attendees that have joined this webinar have joined in listen-only mode, which means that you are muted. If you do have a question during this webinar, please use them in the questions panel of your webinar screen, and we will answer all questions at the end of this webinar. As a reminder, this webinar will be recorded and a link will be sent to you within the next 24 hours. And now I'd like to introduce our exclusive sponsor of today's webinar, B&R Industrial Automation. B&R combines state-of-the-art technology with advanced engineering to provide customers in various industries with complete solutions for machine automation, motion control, HMI, and integrated safety technology. With real-time Ethernet solutions like POWERLINK and Open Safety, as well as powerful automation studio software development environment, B&R is constantly redefining the future of automation engineering. And now I'd like to introduce our presenters for today's webinar, Sari Germanos and Dimitri Philippe. Sari is the Technology Marketing Manager for the Ethernet POWERLINK Standardization Group. His expertise lies in developing complex, distributed, real-time mechatronic applications. He also has significant experience in applying simulation technologies to improve efficiency of developing large-scale distributed systems. Sari received his master's in computer science from Boston College. Dimitri has 15 years of experience in industrial automation with different positions in sales and marketing in the U.S. and Europe. He was the last director of sales at 3S Smart Software Solutions, the manufacturer of Codesys, a standard IEC 61131 engine. Integrated by over 350 automation vendors, Dimitri is founder and CEO of BE.services, a service provider in industrial automation. And now I'd like to hand it over to Sari to begin today's presentation.
Thank you, Joanna. So we're going to start today's presentation by me talking a little bit about machine architecture and performance, and we're going to talk about how this is related to real-time Ethernet and why real-time Ethernet is a requirement for control automation. We will then talk about the high performance requirements for motion, how they are implemented in an open source standard called the Ethernet POWERLINK. We will then talk about a few use cases and show some market adoption data. Then I will hand it over to BE.services, where Dimitri will talk about the Codesys technology and the Codesys environment. He will show how POWERLINK is integrated into that environment and how you can benefit from it. So let us begin. If you are a machine builder today, this picture might be something you recognize. This is a picture of a standard machine today where you might have a PLC that is controlling the machine, and there are several buses connected all together to constitute the entire machine. In this case, you have a bus that's doing access control. So then you have another bus that's possibly doing some I/O and some remote sensors control. Then you might have a third bus doing a safety system. The problem with this type of architecture is that you have a lot of bus systems, and in order to control this environment, you probably have to have different tools to do the development, and then diagnosing a system like that and trying to correlate the sequences in the machine can be quite complex, and deployment and maintenance can also be an issue. So in the ideal world, you'd like to be able to take a system like that and collapse it, so that instead of having all these buses, you would collapse it down to one bus, and you end up with a structure that looks like this. So in this case, you have one technology that is being used for the communication, and that gives you an unlimited degree of freedom in machine design, and diagnosing a machine like this, commissioning it and maintaining it becomes very easy. So in an ideal architecture, you have one network. That's the backbone of all communication for all your discrete devices in your machine. And everything in that machine is connected to that one particular network. Here you might have some pneumatics, visualization, robotics, some safety, some motion control. Everything will be sitting on that same network. So the way that this is made possible today is using Fieldbuses. Fieldbuses have been around for a long time, but the problem with Fieldbuses is that they traditionally have limited bandwidth. Even though they are real-time, they cannot handle a lot of data, and they cannot handle very high frequencies. So as machines get more complex, it becomes necessary to have several buses going through the system in order to handle the bandwidth. So what Ethernet brings to the table is the ability to have a larger amount of bandwidth and a much higher frequency of machine update. The problem with Ethernet is that it is based on CSMA CD, so you end up with collisions, and collisions means retransmits, and retransmits means that you're going to have non-determinism. So the way people generally get around this problem is by using switched Ethernet. Now, switched Ethernet was originally developed again for office type of applications. It really wasn't meant to handle real-time requirements. A switch guarantees a specific connection between two machines, a unique connection between two machines, so that when two machines or two components on a network need to communicate, there are no collisions. But then if you have several pairs trying to communicate at the same time, and you need some real-time response, then the standard off-the-shelf switch cannot be used. You have to use a smart switch that is going to be configurable to the architecture of the machine that you're using. And you also have some clever routing algorithm that has to run, and that routing algorithm has to be, again, unique to the machine that you're building. So commissioning a switch like that can be quite complex. Switches also add inherent delays as you're going from one hop to the next. And lastly, they're also quite costly. So we would like to propose a solution where we don't use switches. Instead, we would like to use a network that is able to eliminate Ethernet collisions without the use of switches, and therefore not worry about the expense and delays, etc., that come along with a switch. So if you think about the real-time network requirements for a machine, you want to have something with real-time performance and high efficiency. You need some large asynchronous bandwidth, because today a lot of machines have to pass large amounts of data around. You'd like to have a single network for all automation, because we discussed that. A flexible network topology is important, so you're not limited to having a ring or a star configuration. If you think of a typical machine cabinet today, you might have a section where there are a bunch of drives sitting next to each other on the network. You'd like to be able to daisy chain those guys together. On the other hand, in another part of the machine, it might make more sense to be able to fan out into a star configuration. You'd like to have something that's hot pluggable. High availability is becoming very important. Immunity to noise is an issue anytime you have any kind of mechatronics. And lastly, again, you need to be able to maintain this machine and service it in the field and diagnose it during development. So that's also an important thing to consider. So let's take a look at the first two requirements. I'm going to describe a protocol called Ethernet POWERLINK that is used predominantly today in machine design. The nice thing about POWERLINK is that it eliminates Ethernet collisions without using switches. The way it does it is there's a concept of a network master we call the managing node, and then everything else on the network is called a control node. There is a concept of a cycle. Every cycle, every component on the network in each cycle is able to communicate and transmit one update packet that it has to publish. So the cycle is actually split into two phases, a synchronous phase and an asynchronous phase. During the synchronous phase, each component can publish data that is specific to the sequence of the machine. During the asynchronous phase of the cycle, you can publish things like status data or anything that is based on standard TCP/IP or standard IP communication. So this is what your cycle time looks like. It's got both synchronous and asynchronous phase included in the cycle time. And the cycle starts with the PLC putting out the start of cycle frame, which now starts the sequence, and then it sends pull requests to each node. Each node receives a pull request, puts out its data. So here's the second node now responding, and then the last node responds to the last pull request. And then finally, you send out the start of asynchronous frame that starts the asynchronous communication. But in this method, you guarantee that there are no collisions because nobody ever speaks out of sequence. So any message or any packet that goes on the network is a packet that's expected. And so long as you are able to respond in a jitter-free environment, so you have the right hardware set up on every single component, you can have a network that's highly utilized, up to 90% utilization or even above, and still guarantee real-time performance without having any collisions or retransmits. So this makes it very easy to design a machine because the data that you expect to arrive will arrive because that data is going to be published every cycle. And the cycle time can be quite low, so it is quite common to see very large networks running at a 400 microsecond cycle time. Another cool thing is to be able to share data between nodes. In a lot of field buses today, if an encoder needs to pass a value to an axis of motion using the network, that value will normally go up to the main controller and then be sent back to the axis. In POWERLINK, nodes can communicate directly with each other. The way this happens is by using broadcast communication. So here's the cycle going on again. Start of cycle frame goes out. The first pull request goes to the first encoder. The encoder responds. The response goes to everybody at once. And this allows a component that is waiting for this data to respond within the same cycle. So you end up with microsecond response time when you're using networks like this. Having one network for all automation, well, what's the big deal here? The big deal is that some components may be high-frequency components that you need to read out every cycle. Other components could be low-frequency components, say temperature sensors or pressure sensors where the values don't change very often. So POWERLINK allows you to do some multiplexing. So if you take a look at the first cycle, components 1, 2, and 3 go every cycle. Then 4, 5, and 6. And the next cycle, 1, 2, and 3 go again. Now 7, 8, and 9 use the same time slots. And then 1, 2, and 3 go again. And then 10 and 11 use the same, those time slots. So in this case, we're showing how 8 data frames are being multiplexed into 3 time slots. This is a form of efficiency. Another thing is instead of sending an individual pull request to every component on the network, you can send out a generic pull request. And then you can have all the components that are supposed to respond in the order they're supposed to respond, but they basically have fixed time delays to guarantee that there are no collisions. So this mode is called pull response chaining, and that's just another form of efficiency in POWERLINK. In terms of hot pluggability and high availability, hot pluggability is not a big deal anymore because everything is Ethernet based, and so it's easy to plug in a new component without having to bring down the machine. But what you can keep in mind here is that in ring architectures, like using things like EtherCAT or Circos, if you unplug a component, you've broken the ring. Whereas in POWERLINK, you can unplug a component without breaking the ring and plug it back in, and the system can continue to operate. So in this case, we show how a PLC can be daisy-chained into a bunch of I/O because every POWERLINK component is required to have 2 Ethernet ports that are connected internally by a repeater. So on one side, you could have a bunch of stuff that's daisy-chained. It could be a bunch of drives in a cabinet or some combination of I/O and drives. On the other hand, you can go through a hub, and I mean a hub here, not a switch, and this will allow you to fan out. And the reason we use hubs is because the propagation delay is much less using a hub. In terms of high availability, POWERLINK has 3 forms of high availability. The first one is what we call ring redundancy. In ring redundancy, you have a master that is then daisy-chained with a bunch of components, but then we take the last component and connect it back to the master. So this forms a ring, but it's a special kind of ring because when a pull request goes out on one line, you listen to it on the other side. If it doesn't come back, you make the assumption that a cable is broken somewhere. So then you start transmitting on both sides. So if you have only one cable broken in the network, your system will continue to run. But you know that you have a broken cable, so you can report a problem and wait for the machine guy, maintenance man, to come back and fix it. But in the meantime, your system is still operating. There's also a form called full medium redundancy, where every component in the machine is connected to two concurrent networks. The connection is done by a link selector. The link selector is able to determine if a network goes down and automatically switches to the backup network, and the system continues to run. Lastly, there's something called a redundant master, where if your master dies, you can have up to 9 additional redundant masters waiting to take over the control. In terms of EMC, POWERLINK actually turns out to be very immune to noise. The reason is that POWERLINK packets generally contain only one piece of data from one component on the network. Whereas if you think about the protocols such as EtherCAT or CIRCOS, where you have one large frame going out around the network, collecting data from all the components as it continues around the ring, by the time it comes back to the master, it's cut all the data from the entire cycle. If you end up with a spike at that point, some kind of a noise spike on the network, you will lose the entire cycle. With POWERLINK, if you have a spike and it corrupts a frame, it only corrupts one frame, and that's only one piece of data from the cycle. So you haven't lost the entire cycle. And so your susceptibility to noise with protocols such as EtherCAT or CIRCOS go up significantly compared to POWERLINK, which where the immunity to noise is only linear. Lastly, if we think about decommissioning and maintenance, because we're using broadcast messaging and because we're using hub technology, packets are not hidden from anybody. So you can take a tool like Wireshark, plug it into the network, and you'll be able to see every packet on the network as it's going by, and you can see the entire sequence of the machine, and you can look at things like response times as well as jitter in the system. So it's very, very easy to debug a POWERLINK network using standard tools off the shelf like Wireshark and OmniPeak. In terms of implementation, in order for a component to be able to respond at a very high frequency to a pull request, you need to be able to respond within a couple of microseconds, and you want to have minimal jitter. So if you're going to be running at very high data rates and at very high frequencies, you need a response time in about 2 microseconds. You end up using an off-the-shelf ASIC that is designed for protocols like POWERLINK, or you can use things like the Intel i210 or the Citara platform used from Xilinx and Altera. The good news is that you have a large variety of hardware to look at and use based on your volume and your application and your own expertise. Just to give you an example of performance, there's a company called Bruckner in Germany that designed a 2-dimensional stretching machine. So this is a stretching plastic for things like your laptop and your LCD TV at your house. In order to get this even level of stretching, they have 728 axes of motion running in complete synchronized mode. So every 400 microseconds, you're updating the axes, the axis control for each component. So as you can see, this is quite an accomplishment, and this was all done through POWERLINK. Another thing to consider is that in China in 2011, the Chinese government made POWERLINK a GB/T standard. GB means it's government approved, GB/T means it's government recommended. POWERLINK was the first standard to become government recommended in China, and as a result now we get about 24,000 downloads a year from China just of the POWERLINK stack in the open source domain. The POWERLINK stack itself is maintained by the Ethernet POWERLINK Standardization Group, which is an open vendor group. It maintains two standards called safety. Our source code is available on SourceForge. It is based on open standards. And in terms of market share today, about the entire market of machines around the world that are using industrial Ethernet. Ethernet IP and Profinet today are about 30% of the entire market, but those applications generally are not real-time applications. They cannot run many nodes at 400 microsecond cycle times. So the only two standards out there that are accepted in terms of being real-time performance on POWERLINK are POWERLINK and EtherCAT. So POWERLINK is running at around 9% and EtherCAT is running at around 77%. So POWERLINK is really about 60% of the real-time market today. So we estimate that we have about 3,500 OEMs today developing POWERLINK systems, and we have about 2 million POWERLINK machines or so deployed.
Yeah, sorry to interrupt you real quick. It looks like you cut off, the audio got a little fuzzy there for the first two bullet points. I don't know if you want to go back over them. We heard the last two on the last slide.
Oh, I'm sorry about that. So
that's okay. We heard most of it.
Yeah, so all I was saying there is that POWERLINK is maintained by the Ethernet POWERLINK Standardization Group, EPSG, and the fact that POWERLINK is an open source protocol. So that's the only thing that people missed there, so I apologize for that. So I'm going to hand this over now to Dimitri, and he will start talking about the integration of POWERLINK into the Codesys environments and how that is all integrated and how you can benefit from it.
Well, thank you, Sari. Thank you very much for this interesting presentation. It looks like there is something on the display. Okay, that's better now. Okay. So my name is Dimitri Philippe. I'm representing the company BE.services. BE.services is an embedded software technology and services provider in industrial automation. And as part of the projects that we have, we've had requirements from the market to integrate two important technologies that are POWERLINK and CODESYS. We are a system integrator for the Codesys Technologies that is used mainly for master control systems, and combining the Codesys technology together with POWERLINK is a wish that we see in the market. So I'm going to present that in a few words. First of all, I'm going to talk about Codesys itself. Codesys is a technology from the company 3S Smart Software Solutions. It's been in the market for about 20 years, and this has become a leading manufacturer-independent IEC 61131-3. For those that are not familiar with this norm, this, besides other things, it describes and standardizes on 5 programming languages to make it easier for automation engineers to develop applications. And Codesys supports these languages, and when we look at and we talk about the Codesys technologies, we really need to see two different parts. On one side, there is the IDE, which is a free of charge software that can be downloaded directly from the 3S website at Codesys, www.codesys.com. And this includes a lot of different features, mainly including the IEC 61131 languages. And this allow any automation engineer to develop a complete automation application. And once you have this application, you need the counterpart. You need to be able to execute this application, and for that you need on the PLC, or in general in the control system, you need to have the Codesys Runtime System. And the Codesys Runtime System is integrated by the automation vendor to make their controllers programmable with Codesys. This is an alternative to having C as a programming language for a controller, so it's much more convenient and suitable for automation engineers to use more standardized tools like Codesys. So today there are about 380 automation vendors that have decided to make their controllers programmable with Codesys for about 1 million devices produced in year. So about 1 million devices that are programmed by Codesys are produced every year, and this is a growing number. So how does the Codesys technology work? How is it distributed? Well, basically 3S, the manufacturer, together with some of their with their distributors present in different countries all over the world, they basically sell the runtime system as a toolkit to the ICS vendor that needs to integrate that runtime system into its controller. Then the vendor sells its controllers to the end user. So typically the end user is a machine builder or a smart grid integrator, or power plants, or application in the mobile industry, crane manufacturer, or any equipment or any construction machine. And 3S also uses a lot of system integrators worldwide to help the end user develop the Codesys application. So you have companies that develop applications for the end user, and the end user that uses the standard Codesys tool has also the possibility to download and to use additional functionalities that are not delivered in the standard free of charge IDE over the Codesys store, which is basically a similar thing than the App Store from Apple. So when we talk about Codesys, yes, it is an IEC 61131 tool, but this is not enough. In 20 years, the company 3S has been extending Codesys, bringing new versions, but mainly bringing a lot of additional features. So I just want to give you an overview of what is available in the Codesys technology. In the engineering part, which is basically the IDE itself, it supports the 5 IEC standard languages that are defined by the IEC committee, the IEC norm, and it also adds CFC. So the 5 languages are ladder, of course, sequential function chart, function block diagram, structured text, and instruction list. But you can also have additional languages. And also what 3S does is they keep developing new functionality, like adding object-oriented programming, for example. All the functionalities that are used by more than 70–80% of the engineers are added in the free part of the software. Additional features that are not necessary for all the engineers are developed and marketed over the Codesys store, and these are pretty neat features, like a direct integration in Subversion for version control of the applications, a UML editor, for example. Application Composer is very nice as well, that allows higher skilled engineers to develop application modules, test them, and provide them to the application engineer. So it just has to put the modules together, and then all the code is generated in the background. Then you have tools like Profiler, automatic test with the test manager. So this is a technology that is used a lot, but of course it's not it's not just like it is, and it keeps bringing new functionality to answer the market requirements and to be closer to high-end engineering development. Then the counterpart, as I mentioned, the Codesys Runtime System. What has made 3S and Codesys very successful is that the Codesys Runtime System is extremely flexible. It can be adapted, integrated on many different type of hardware platforms, going from low-end tri-core or ARM processors all the way to multi-core x86 platforms. It can be used on bare metal platforms, so without operating system, but it can also be provided pretty much off the shelf for Windows, Linux, QNX, VxWorks, and even other operating systems. So it can really be used on low-end control systems, and the very same technology can be used on high-end architecture. 3S has recognized that that automation engineers want to be able to use one single tool to develop a complete automation application. So besides the standard logic control, there are lots of important functionality in Codesys, one of them being the visualization. There is a screen designer in the free of charge Codesys environment, and you can develop your screens, and you have different possibility to display those on different clients. So either the controller itself has a screen, in which case you can display that visualization directly on the controller. So this is part of the application, and this is executed by the runtime system. Another possibility is to add a web server in the runtime system, so an additional component which gives the possibility to display the visualization screens in the web browser. And a third client option that 3S provides is to have a standalone runtime system executing strictly visualization code. So this is for high-end HMI and SCADA systems. But the most important is the design of the application, and the design of the visualization screens are made in the same tool. What is also available is, besides the visualization and the logic control, the I/O control, it's also possible using additional free of charge editors to develop a complete motion and CNC application. So the PLC Open function blocks for single axis and multi-axis are supported, PLC Open being an organization that supports, extends and markets the IEC 61131 standard. And also you will find in Codesys additional editors for CNC. So you have a G-code editor, both textual and graphical. And also libraries for robotics and extensions for robotics are available in Codesys. Another important feature is the safety. So Codesys Safety is not a different product. It's an additional feature completely integrated in the standard Codesys. So it is basically possible to develop a non-safe application and a safe application in the same project. And you can develop applications according to the 1508 standard for SEAL 2, which is mainly for applications in construction machines, and SEAL 3, that is mainly used in factory automation. So it was important to present the Codesys technology because the POWERLINK technology, which is open source, which is very performant, is of interest to many companies. But of course, it's important to have a way to implement a master POWERLINK controller, and Codesys is the suitable technology because it also brings lots of advantages, like the free of charge IDE, the compliance to the 61131-3 standard, which allows easy programming for skilled and maybe less skilled engineers. The fact that you can do complete automation applications, not just the I/O control, but also motion control, the HMI, safety, everything in the same environment. What is also neat are all the extensions on the Codesys store, which is very, very useful. That's also, by the way, also provides free of charge products as well as free of charge project examples. So it's a very good source of information for those that want to use Codesys. For machine builders, it is very important to understand that 380 ICS vendors have decided to use Codesys as the technology to program their controllers. So it gives a very, very wide choice of the type of controller that you can use. Especially the fact that the code that was developed for a certain brand using Codesys can be reused even if the controller is exchanged with a controller from a different brand. So that's very important to be able to reuse whatever code has been developed if the controller has changed or if the vendor has been changed. Also, what I didn't mention is that Codesys has integrated compiler. So the IEC code is downloaded directly in native code for the different CPUs that we mentioned. And for those that would like to use Codesys to develop their own controllers, an ICS manufacturer, or a machine builder that would like to develop own control system, then there is very probably the possibility to use Codesys on that controller. So after having gone through the advantages and what the benefits are for using Codesys, I would like to just remind a few things that Sari told us earlier. So POWERLINK is very, very widely used all over the world. I think Sari mentioned 3,500 machine builders using the technology, so it's proven in the field. It has excellent performance. It also can be used for safety, for motion control, for I/O, and additional automation components. It is very close. It is basically CANopen over Ethernet. So for those that have been using CANopen and look at switching into an Ethernet-based Fieldbus protocol, then POWERLINK is the obvious choice. It is patent-free. That is also very important. It's manufacturer independent, and it's an open source solution. So we thought at BE.services that it would make very good sense to combine both POWERLINK and Codesys. And what we've done is integrating both technologies. So if we look at this picture, so we recognize what we saw earlier. So we have here the IDE. We have here the PLC, or the industrial control system, and we have the I/O level. So the IDE comes from 3S, can be downloaded for free, and we have developed an additional editor, which is a plugin that can be downloaded and installed directly in Codesys for the configuration of the POWERLINK network, configuration both of the master and of the slave device. At the embedded level on the controller itself, so there is a real-time operating system running, or maybe not, and then you have the Codesys control runtime system that needs to be installed on the device. The open POWERLINK stack, as Sari mentioned, is open source and can be downloaded and integrated directly at the embedded level, and we have developed an additional component in the runtime system to basically interface the Codesys runtime system with the open POWERLINK stack. At the I/O level, then the controller becomes turns into a POWERLINK master, and we have an Ethernet POWERLINK Fieldbus network running with I/Os that are POWERLINK control nodes. So what functionalities are available? So in the plugin, you have the configuration both of the master and the slave, or the master node, the managing node, and the control node. You can configure all the parameters. You have the PDO configuration, like you may be familiar coming from CANopen. The possibility to have device-specific parameters. We support the poll response chaining and the polling mode. Modular devices is also supported. There is the functionality to, instead of having a manual configuration of all the I/O modules, to have a scan for devices to be able to automatically upload whatever I/O system you have in the application. Lots of diagnostics and additional configuration. So what I would like to do is switch to the Codesys environment and show you how that plugin works to integrate POWERLINK into Codesys. So this is the Codesys environment. So I'm just gonna go by opening a new project, a standard project. We need to give a title, and we're gonna call it POWERLINK Codesys. So Codesys is launching a couple of libraries in the background. The first thing that Codesys wants to know, and remember I said that 380 manufacturers are using the standard Codesys. That means that Codesys can be used to program lots of different devices. So it's necessary to tell Codesys what is the target device that we're actually using. So here are a few target controllers that I have installed on my PC. So for this demo, I'm going to use the Zinc evaluation board from Xilinx, on which we have ported the Codesys runtime system and integrated the open POWERLINK stack. And the main PLC PRG, this is the IC wording, the main program will be in structured text. So here we go, the project is getting created. So you see we have the tree view, and we have our controller here on which we want to add, or maybe we want first of all to check the communications. I'm just going to scan the network to find that device. So from my laptop, I'm connected to the controller itself, which is that evaluation board in this case. So it's active now. That's very good. And in order to do the configuration of the network under the device, we need to add a device, and then we're going to POWERLINK, and we need to make that device a POWERLINK master. So we are adding the components here, and as you see, now I have the possibility to do configuration of the master, and I come back to that. What I want to do now is to add IO slave. So I have an X20 IO module from BNR here in my installation. So what I need to do is first of all to install that device. So POWERLINK, and I need to install the XDD or XDC. This is the description format for POWERLINK devices. So I'm now installing that device, and you see Codesys saying that this has been installed, and I've got the information. So this is the X20 IO module from BNR. So that's perfect. So now I can, under my master, I can add that IO module, and now I've got in my application, I've got both the master and the managing node and the control node that I can use. So let's have a look at the configuration. So I need to select the Ethernet adapter that I'm using for the POWERLINK bus. Then I've got the possibility to do some parameterization, configuration, the cycle time, for example, the SOC tolerance. I've got some diagnostics and information then going on the slave device. Then here I've got possibility to add the node ID, poll response timeout, some further configuration. And here you see process data object and service data object. So what I'm going to do is just simply add a couple in the, sorry, this has popped up on my other screen. So I'm going to add some digital output and some digital input. And once I've done that, the configurator has automatically done the POWERLINK IO mapping, where you see I've got these two components here, so I can do byte or per bit. And what I'm going to do is just to show how quickly you can configure and get an application running. So I'm just going to name those. And when I go into the project itself, so this is where now we can write the logic in Codesys. So you have here the declaration of the variables, and on the bottom part you have the code. So what I need to do first in order to get the cyclic input update, I just need to create that variable, which is in. So I have now the update cyclically. So Codesys has a nice feature with the auto-declare functionality where you can, if there is a variable that is used and that is not been declared, then it can be automatically recognized by the tool. And then I'm just going to have a simple counter. Okay, and then if I want to go online with the device, so Codesys is telling me, okay, there is another application running, so I want to add a new application, and I say yes, so it's now downloading the application.
Dimitri, just while that's downloading, we are getting close on time, and I do want to get to some questions. So if you want to wrap it up.
And I'll be finished in 2 minutes, if that's all right.
Sounds good. That sounds great.
Thanks, Joanna. Okay, and I'm just starting my application, and you see now we can see directly in the application the code the application running, but we see also directly in the configuration that this is really running on the bus. So let me just go back to and that's all I wanted to show you on this integration. So you have a look at it. So who should take advantage of this combination of the technologies? So I think the machine builders that use Codesys and that really need best performance, they can now really integrate also and use POWERLINK together with Codesys. On the other side, those that have been using POWERLINK and that maybe didn't have a user-friendly environment like Codesys can now do that as well. And surely the ICS manufacturers that want to provide both technologies to their clients. So again, the combination of both technologies can be used really on small systems as well as larger systems like IPC, and even for those wanting to develop their own hardware can use both the technologies. And company BE.services helps in the integration of those. And I had a couple of slides for BE.services, but I think I will invite you simply to go to these links to the company website of the company. We do have an education offering where we provide e-learning for Codesys with a complete 45-hour curriculum, and I invite you to have a look at these links. All right, and I finish up here.
Very good. Thank you, Sari and Dimitri, for that very informative webinar. And at this time, we did want to open it up to questions for the audience. So if you did have a question for Sari or Dimitri, please type it in your questions panel, and we will ask it. So it looks like we did get one that came in earlier. The first question is, what is the advantage of node-to-node direct communication? Sorry, or Dimitri, or sorry, I think you might be on mute. I think I see you talking.
That's probably a question for Sari.
Yeah.
Sorry about that, I was on mute.
No problem.
Yeah, so the main thing here is that when you need to have very fast reaction time, if you're trying to synchronize more than one axis to a common encoder, the nice thing is that when one component publishes a value, that value is seen immediately within the same cycle by the other components. So the reaction time can be a matter of microseconds as opposed to a fraction of a millisecond.
Great. Second question is how to integrate Codesys Runtime System on a proprietary software, the costs and steps.
Well, for companies that want to develop their own controller, they need to get in contact with 3S or the local official distributor of Codesys, and first of all, runtime toolkit for specific platforms. So this depends on the platform means the CPU and the operating system combination. And 3S delivers that runtime system that then needs to be integrated. There is some integration steps. Depending on the platform, it can be more or less steps. But this is something that that usually the manufacturer can do himself, and some cases where they don't have the knowledge or maybe the resources to do so, this is also where BE.services can help.
Great. Next question is POWERLINK completely open source?
Yes, it is. So you can get onto SourceForge and search for POWERLINK, or just Google SourceForge space POWERLINK, and you'll find the landing page. There you'll find the entire source code as well as the VHDL functionality required for both Altera and Xilinx FPGAs.
Great. Dimitri, I think this question's for you. Is it possible to use Codesys on any PLC?
Well, that's a very good question. Theoretically, yes, but the manufacturer of the PLC has to has to take this decision. So has to make the decision because it is part of the firmware of the controller, and usually the user that buys the commercial PLC doesn't have access to the firmware. So the manufacturer needs to make the decision to integrate the runtime system to make it Codesys programmable. Now, there are other alternatives. 3S also provides ready-to-use runtime systems for different platforms, especially for PC architecture. There is also a version for Raspberry Pi that, of course, is always questionable whether this is suitable for industrial applications. But for those that want to use ready-to-use hardware and add the runtime system themselves, they can go on the Codesys store and 3S market some ready-to-use runtime system. And if you want to find out whether a PLC that you like is Codesys programmable, or if you're looking for a PLC that is Codesys programmable, there is also a very nice tool on the Codesys website called the device directory that lists most of the Codesys programmable devices.
Great, and I think we have time for one last question. And the question is this plugin for POWERLINK and CODESYS compatible with Codesys Soft Motion for the development of motion control code?
Well, that is another very good question. Thank you for asking that. It is not in the first version, but this is already planned for the second version that will be released at the end of this year or later on this year. So the first version supports logic control, so IOs, and the extension to have the possibility to develop motion code over the POWERLINK network or the motion code, and having drives using POWERLINK will be released by the end of this year.
Great. And again, to the audience, if we didn't get to your question, we will follow up with them via email after this webinar has concluded. I wanted to this time stay to our time limit and thanks Sari and Dimitri, and as well as our participants today, and of course our sponsor B&R Industrial Automation. As a reminder, this webinar has been recorded, and the email with the link to the recording will be sent to you within the next 24 hours. If you do have any other questions, please feel free to email us and we will follow up accordingly. And the last thing we wanted to bring up is for those of you who haven't heard, the MCMA is exciting to announce its technical conference in the French Quarter of New Orleans, Louisiana. The dates are October 11th through the 13th. The conference will focus on technical training in areas of motion control technologies, electric motors, software interface, network communication, and related technologies. We will also have a full tabletop exhibition of industry suppliers and networking events. It is an industry must-attend event, and we do hope that you'll join us. And again, be sure to visit www.motioncontrolonline.org for information about our technical conference or any upcoming webinars. Thank you again, and have a great rest of your day.